As we get started today, go ahead and make sure you have your speed drill and review exercise booklets out. Speed drill and review exercise booklet. Turn to page 6 in your booklet. Page 6 in your booklet, we're going to do speed drill number 9. Speed drill number 9, you will have 4 minutes. Some various multiplications, some involving decimals, some involving fractions. I would not work these in order. Some of these are considerably easier than others. Some of them look downright frightening. So do not work them in order. That's just my advice. You do have 4 minutes to get as many done as you can. Hopefully that's all of them. And you may begin. One more minute. Good, Danielle's finished. Good, Glenn. All right, stop. Put your pencils away, take your pens out, and exchange with the other person in your row. Pencils away, pens out, and exchange with the other person in your row. Sign your name at the bottom of the page as the grader, if you would, please. Sign your name at the bottom of the page as the grader. And let's take a look at these now. Going across the top row. That first one I would have done right away. That's a really quick, easy one. As long as you're careful with your decimal, she'll get 2.61. 2.61.
But they have the numbers, but the decimals not.
No, it's wrong. That's all part of the point of the problem was to practice putting the decimal in the correct place. All right, the next two I would have done last because they just look ghastly. Number 2, the second one on that top row, 3,276.9875. 3,276.9875.
Are we doing the comma thing?
Minus the point if they forgot their comma. But if the decimal's in the wrong spot, it is wrong. Again, that's part of the point was to make sure the point, I get it, decimal point, anyway. To make sure the decimal's in the right spot. Jaden laughed, it's okay, I feel better. All right, next one. No, I don't feel better, okay, Evie disagrees. All right, Evie's crossed off my teacher's pet list. All right, next one, 100, she was never on it, 116,975.84. 116,975.84. And then as we go down to the bottom, remember you've got to change these mixed numbers to improper fractions. Then do some canceling, then do your multiplying, and then go back to the mixed number at the end. So our answers should be 14 1/2, 14 1/2, and for the last one, comes out evenly to 52. 52. All right, if they got all of them correct, of course, that's a 100. If they missed just one, it's an 85. Minus 2 is a 70. Minus 3 is a 55. Minus 4 is a 40. And if they missed all 5, it is a 0. So again, 100 if they missed none, 85 if they missed 1, 70 if they missed 2, 55 for 3 wrong, 4 wrong is a 40. And if they missed all 5, it's a 0. Put the score there also on the score page. Put the score on the speed drill score page. You'll notice that is the last one of this quarter. We will have no more the entire rest of the quarter, which is like 3 more days. Because in lesson 40, for those watching on YouTube, lesson 40 will be your exam. Hayden, since you're out today, I'm sending this to you as well. Wednesday will be your exam. So Wednesday will be that exam. All right, any hundreds today? You got all of them right. How about an 85? You just missed one. Okay, good, a couple. Maybe 70s, just missed a couple, but still passed. All right, pass those in if you would, please. I'll collect those from you. Take your books out, open to page 92. Pass those in if you would, please, and then open your textbooks to page 92. And on pages 92 to 93, you did numbers 12 through 36, the even numbered problems. 12 to 36, the even numbered problems. Let's take a look at that homework. Again, part of your exam review, even now, doing a little review here and there. Numbers 12 to 36, the evens. Good. All right. Good. Page 92. Bueno. Good. And good. All right, let's go ahead and take a look at these together. Number 12, 240 seconds. How many minutes, Aubrey?
4.
4. We have to divide by 60 because we're going from smaller to larger. Number 14, we just move the decimal, boink, 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 from the C to the H, and from the chocolate to the Henry. And what do we get for our answer, Evie? 0.00035. If you were a smart aleck and wrote 3.5 times 10 to the negative 4th, that is also correct, just a little weird. And number 16, 96 pints to gallons using dimensional analysis, going from pints to quarts and then quarts to gallons to get what? Glenn? 12 is our answer, 12 gallons for number 16. Number 18, subtracting, having to do a little bit of borrowing here. Michael, what did you get on 18?
13 bushels, 3 pecks.
13 bushels, 3 pecks. Number 20, we're multiplying by the 9 and then changing some units over, Danielle. 183 pounds, 15 ounces. We stole 3 pounds from the 63 ounces. The number 22, what did you get for that, Lexi?
5 pints, 1 cup.
5 pints and 1 cup is correct. And then we go 6 for 6 on those first 6 problems. All right, any questions on those first 6? We're dealing with measures. Yes, ma'am.
On 22, I got like the 5. I'm just confused about the cups.
All right, so we've got the 16 pints, 1 cup being divided by 5. That wasn't 1 cup. Yeah, it was. Divided by 3. Okay, that's it. Divided by 3. 3 goes into 16 5 times, so there's your 5 pints. And that leaves you with 1 pint left over, right? But a pint becomes how many cups? 2 cups. But we already have 1 cup, so really we've got 3 cups. Divided by 3 is 1 cup. All right, good. Any other questions on those first 6 homework problems? All right, let's take a look at number 24. And dealing with that relay race thing. And remember yesterday we were given 4 individual times. It was said what was the total time. Well, here in number 24, a competing team ran the same relay in 5 minutes, 4 seconds. So evidently the first relay team won, because if you remember, their answer was 4 minutes, 45 seconds. But the competing losing team ran in 5 minutes, 4 seconds. What was the average time for each runner? What do we have to do here, Danielle?
You have to divide by 4.
Divide by the 4 runners to see the average time for each. That doesn't mean every runner actually ran that, but that would be the average of all of them. And when we divide by 4, we get
1 minute, 16 seconds.
how many also had 1 minute, 16 seconds? All right, Aubrey, what was your answer?
I didn't do that because I didn't know like if you divided or not.
Does that make sense, though, to find an average? Because normally, if we wanted to average things, for instance, what I'm going to do with your speed drill grades, I'm going to take all the different grades, I'm going to add them together to get what we call the sum, and then I'm going to divide the sum by the total number of grades. Well, in this case, I know the sum is 5 minutes, 4 seconds? Yeah, 5 minutes, 4 seconds. And I know there were 4 total runners. I don't know what the individual times are, but I know there's 4 runners. So if I divide by the 4, that'll give me the average. Make sense? All right, number 26, writing in scientific notation. Let's go back to Aubrey.
4.52 times 10 to the negative 3rd.
Good, 4.52 times 10 to the negative 3rd. Number 28, what did you get, Michael?
9.4737 times 10 to the 5th.
That thing's just ugly, isn't it? Yeah, what's the point of scientific notation if there's not a whole bunch of zeros you get to lose? But again, as we mentioned once before, part of the point is you would normally round that number off to significant digits. You'd have a bunch of zeros, then write it in scientific notation. So instead of writing so much, 9.4736 times 10 to the 5th, you're not writing as many digits before the times 10 to the 5th. Number 30, what did you get for your answer, Glenn? 7.4 times 10 to the negative 4th is correct. Going to the top of the next page, number 32, writing the number in standard form, Evie. 0.026. Number 34, Danielle.
2,400.
2,400. And then number 36, Lexi.
0.000043.
Good, 4 zeros in there. 0.000043. Anyone perfect on the scientific notation stuff? All right, all of you in here, excellent. Any questions at all on the homework? I want you to drop down now, page 93 at the bottom of the page in the homework section. I want you to do numbers 14 through 18. We're working with something we practiced yesterday, is adding scientific notation. So page 93 in the homework section, to numbers 14 through 18, adding or subtracting the scientific notation. Remember, we said to add or subtract scientific notation, class, what must be the same?
The power.
The power of 10. As long as the power of 10 matches, we can add and subtract. And, as we said, in 8th grade, they're all going to match. Let's go and take a look at our answers here. Number 14, what did you get for your answer, Aubrey?
9.7 times 10 to the negative 7.
How many had 9.7 times 10 to the negative 7? Really straightforward, right? Number 15, how many? Oh, not so really straightforward?
I did it right.
Okay. All right, number 15, what did you get for your answer there, Michael?
0.4 times 10 to the 9th.
careful there. We borrow from the 5, make that a 4, but the 1 comes over and makes it an 11 minus 6. Should have given us, class, 0.5 times 10 to the 9th. 0.5 times 10 to the 9th. Number 16, for redemption, back to Michael.
16.0 times 10 squared.
Good, 16.0, or you could just say 16 times 10 squared. Number 17, what did you get for your answer, Evie?
5.2 times 10 to the negative third.
Good, 5.2 times 10 to the negative third. And then number 18, what did you get for your answer, Danielle?
14.9 times 10 to the negative fifth.
Good, how many had 14.9 times 10 to the negative fifth? Now, I want you to look at the answer for just a moment at number 15. We said 0.5 times 10 to the negative 9th. Is that number written in proper scientific notation? No. Look at the answer on number 16. 16 times 10 squared. Is that written in proper scientific notation? Look at the answer number 18. 14.9 times 10 to the negative fifth. Is that written in proper scientific notation? So there are going to be times then that as we work, we're going to have to fix our answers. That's what we're going to talk about in our lesson today, is writing proper scientific notation. A couple things as you flip back, we're going to look at these here in just a moment, but flip back to page number 88. Correction, flip back to page number 87. All right, page 87. Proper scientific notation, again, means you have to have a number that is has just the 1 digit before the decimal, right? 1 digit before the decimal. So what do we do when it comes out kind of weird? Well, in this case, we see that the point is after the 6, and I need to move it between the 1 and 6, right? Because the number here is too big. Does that make sense? 16 is too big. You're only allowed a single digit number. So what I'm going to do is move the decimal over to get 1.6, but since this is big, I should make the exponent bigger to go to a 10 cubed. Does that make sense? Do you see here the number's too small? It has to have a digit before the decimal, and it doesn't. I should have a number 1 through 9 here, and I don't have that. I have a 0, which is too small. So I'll move the decimal backward to get 5 point, or just 5, and I'm going to have to make the exponent smaller. What's smaller than negative 9? Not negative 8, that's bigger. Negative 10, right? Remember, the numbers get smaller. 4, 3, 2, 1, 0. They're getting smaller. Negative 1, negative 2, negative 3, right? More negative means smaller. So here we're going to go to a negative 10. What about here? Is the number too big or too small, class? It's too big. I should have 1.49. So since this number is too big, I should make this exponent bigger. Now question, what's a little bigger than negative 5? Not negative 6, that's smaller. Negative 4, right? There's that reverse thinking on the negative exponents, isn't it? I want you to write this in the side margin of your book. If the number is less than 1, if the number is less than 1, so less than 1, move the decimal and lower the exponent. If the number is less than 1, move the decimal and lower the exponent, or make it more negative if it's a negative exponent. If it's too big, if the number is more than 1 digit, so more than 1 digit, move the decimal, raise the exponent. If there's more than 1 digit, move the decimal, raise the exponent. Does that make sense? So we adjust at the tail end of the problem in some cases. So if the number is less than 1, meaning it's too little, lower the exponent as you move the decimal. And if it's too big, it's bigger than 1 digit, then move the decimal and raise the exponent. Look at page 87, the example 2.6b. They give you 0.67 times 10 to the 8th. Well, in that case, I need to move it backward, right? 0.67 is too small, correct? So move the decimal backward 6.7, and I drop the exponent down to a 10 to the 7th power. Does that make sense? Look at the next example. Ooh, 123.9 times 10 to the 9th. Well, here I've got to move the decimal not once, class, but twice to get 1.239. The number was way too big. So since it was too big, I need to make the exponent bigger, but by 2, because I moved the decimal twice. So instead of bumping it from a 9 to a 10, bump it all the way up to an 11. Questions on those examples at the bottom of page 87. You see what we're doing here? Turn over. Example 2.6c. This is what we just did a moment ago with correcting our answers. You look at the problem, letter A in the yellow box. We're good. They're both 10 to the 5th. So we just add them. But when we add them, we get 16.3 times 10 to the 5th. Oh, that's too big. So we move the decimal and we make the exponent bigger because it was a big number. Look at the next example. We subtract. Ooh, Danielle, we're looking at the sample. We're not making any markings in our book right now. And we subtract 5.82 times 10 to the 4th minus 5.8 times 10 to the 4th. They're both 10 to the 4th. We can subtract, but notice we get 0.02 times 10 to the 4th. Well, I should have a digit before the decimal. Notice if I move it back once, that's not enough. That's still 0.2. I got to move it twice. The number was way too little. So I need to make the exponent
Way smaller.
littler, way smaller. Not by 1, not dropping it from 4 down to 3, but all the way down to a 2. Does that make sense? As many places as you move the decimal, that's how many places the exponent needs to change. Does that make sense? So if you move the exponent, I don't know, 4 times. Oh, let's just say we had a 2,307, well, this isn't 4 times. 23,745.2 times 10 squared. Well, here I've got to move the decimal 4 places up to get 2.37452, right? So since I moved it 4 places, it was way too big. I have to bump the exponent up, class, 4 times. I'm bumping it up to make it bigger to get 10 to the 6th. Does that make sense? Right? If it were the other way around, I've got like 0.00371 times 10 to the, I don't know, negative 1st. All right? I've got to move the decimal how many places, class? 3 to get it right here, 3.71. This number is way too small. I need to do what to the exponent? Make it smaller by
Increasing the negative.
3. So if I make it 3 smaller, what's 3 smaller than negative 1?
Negative 4.
Negative 4. Questions on that? All right. So look in your book there at page 89 now. And I want you to do 15, 16, and 17, just rewriting the numbers in scientific notation. Page 89, doing 15, 16, and 17. Page 89, 15, 16, 17. Make them look right. All right, number 15. Glenn, what did you get for your answer? Okay, we're not taking them out of scientific notation. We're actually just making them look correct. So you're not actually, this is another way you could do this, Glenn. You could go from wrong scientific notation to standard form, and then go to proper scientific notation. We need to move the decimal how many places? 4. So we change it to get 1. There we go. I mean, you could do this. This is, to me, the long way, though. Not a wrong way, but a very long way to do it. Does that make sense, though, what he did? But the better way, Glenn, is just, oops, there's 2 digits. I'm only allowed to have 1. So we just move the decimal like that. And there's my 1.04. And since I moved the decimal one time, I changed the exponent one time. Since it was a big number, I make the exponent bigger and get my 10 to the fourth. Does that make sense? But that's what we were shooting for there. So on number 16, what should we have gotten for our answer, Michael?
4.5 times 10 to the 9.
Good, we're moving the decimal backward this time, so we're going to drop the exponent. 4.5 times 10 to the 9th power is correct. And then number 17, Aubrey, what do we need to get?
3.025 times 10 to the 7th.
Good, this time I need to move the decimal 2 places over because the number's way too big, 3.025, and that means I need to bump the exponent up 2 places to get times 10 to the 7th. Great job. How many got 3 out of 3 correct? Glenn, you understand what we were supposed to be doing now? All right, let me have you work numbers 18 through 29. Just add, subtract like we normally would, and then if the answer's written wrong, fix it. Does that make sense? So we're still just adding, subtracting like normal, but if the answer's wrong, fix it. 18 to 29, they're on page 89. Genesis feet down. Start by just adding, subtracting as normal. Then fix the answer once you've got it, if it's wrong. Glenn's finished. just a little longer to be finishing up. All right, for sake of time, pencils down, even if you're not finished with all of them yet, and let's take a look at these together. Number 18, what did you get for your initial answer, Aubrey?
6.8 times 10 to the 4th.
Number 18?
18?
It should have got initially 11.8, right? 11.8 times 10 to the 4th? And then we need to move the decimal over to get what final answer?
1.18 times 10 to the 5th.
There we go, 1.18 times 10 to the 5th. Number 19, Evie, what was your initial answer?
10 times 10 to the 2nd.
Good, 10 times 10 squared, but we move the decimal over to get
1 times 10 cubed.
1 times 10 cubed. Number 20, Glenn, your initial answer? Good, 12.1 times 10 squared, but we change it to? Good, 1.21 times 10 cubed. Number 21, Lexi, we initially get?
15.4 times 10 cubed.
15.4 times 10 cubed, move the decimal, get?
1.540 times 10 to the 4th.
Good, 1.54 times 10 to the 4th for our answer. Number 22, the initial answer. Michael?
0.9.
Times?
0.9 times 10 cubed.
Good, 0.9 times 10 cubed. We got to move the decimal backward now to get?
9 times 10 squared.
Good, 9 times 10 squared, dropping the exponent to reflect the subtraction. The fact that the number was too small. Number 23, Danielle, your initial answer?
0.55
Times
10 to the 4th.
Good, 0.55 times 10 to the 4th, but you changed it and made it correct to say?
5.5 times 10 to the 5th.
Well, remember, you're moving the decimal backwards, so we've got the 0.55 times 10 to the 4th.
Cubed.
Right, since we're moving it backward, we've got this little number. We have to show that the number was little by dropping the exponent smaller. And that would be our final answer there. Number 24, initial answer, Aubrey.
0.4
Times?
times 10 to the 1st.
Good, 0.4 times 10 to the 1st, but you made it?
4 times 10 to the 1st. No,
All right, so initially you subtract, you get 0.4 and keep the times 10 to the 1st, right? Then we're going to move the decimal backward to make it just 4, but what do I do with the exponent?
subtract.
Subtract it down to get 10 to the
0.
0 power, which anything with a 0 power class is just 1, because it's if I have no 10s, I just have 1. So I end up with really, I could just say 4 is my answer, but they wanted it in scientific notation, so this is the answer they wanted, but it means the same thing as 4. Number 25, Evie, initial answer?
0.3 times 10 to the 8th.
0.3 times 10 to the 8th becomes?
3 times 10 to the 7th.
3 times 10 to the 7th. Great job. Number 26, Glenn, initial answer? 12.4 times 10 to the 7th becomes? 1.24 times 10 to the 8th. Lexi, number 27, did we make it that far?
Yes.
What did you get for your initial answer?
0.80 times 10 to the 5th.
Good, 0.80 times 10 to the 5th, which becomes?
8 times 10 to the 4th.
8, or 8.0, I like just 8, times 10 to the 4th. Very good. Number 28, Michael, did you make it to that next to last one? What was your initial answer?
13.9 times 10 to the 1st.
Good, 13.9 times 10 to the 1st, but we change it to get?
1.39 times 10 squared.
1.39 times 10 squared. And the last one, number 29, Danielle, did you get there?
Yes.
All right, what did you get for your initial answer?
0.05 times 10 to the 6th.
0.05 times 10 to the 6th, and when you fixed it, you got?
5 times 10 to the 8th.
Well, are we making it bigger or smaller?
Smaller, 4.
There we go, 0.05 times 10 to the 6. We're moving it 2 places to get 5, so we're going to drop it 2 places to get 10 to the 4th. There we go. Was anyone perfect? 12 for 12. We're perfect on all the ones you did. All right, anyone just missed 1? Just missed 2? All right, the ones that we missed, do we understand it now? So even if we didn't get them all correct, do we feel like we understand it better now? Questions on this? All right, a couple of word problems for you. Number 30 and number 31 at your seats. Number 30 and number 31. Take a couple minutes to work on these. All right, read word problem number 30 for us, if you would, Michael.
The pressure inside an oxygen tank, inside an oxygen tank is 7.6 times 10 cubed kilopascals. If the pressure increased by 3.9 times 10 cubed kilopascals, what is the total pressure?
All right, and so when it says find the total pressure, what do we have to do with our numbers? Add them. When you added them, you got?
Initially 11.5.
Times?
10 cubed.
Good. Initially 11.5 times 10 cubed kilopascals, but you changed that to get?
1.15 times 10 to the 4th kilopascals.
Good. How many had 1.15 times 10 to the 4th kilopascals? Questions on number 30? Any questions on that one? All right, and then number 31, go ahead and read that one for us, if you would, Evie.
1 light year is approximately 9.461 times 10 to the 5th
Meters.
If an asteroid has already traveled 1.2 times 10 to the 15th meters, how much further does it need to travel until it has traveled 1 light year?
All right, what do we need to do to figure how much further it still has to travel?
Subtract.
Subtract. And when you subtracted, you got?
8.261 times 10 to the 15th. Power.
Meters. There we go. The number was correct. Good. And notice this time it came out fine. So don't change it if it came out fine, right? 8.261 times 10 to the 15th meters. That's happy. That means we don't have to change anything. We can leave it just like that. How many also got 8.261 times 10 to the 15th meters? All right, questions on that? Turn back to page 93. Turn back to page 93. Then I want you to do numbers 37 to 45. Page 93. Doing numbers 37 to 45. Not all of these will need fixing, but if they do, be prepared to fix them. fast. In a moment we will see if he is accurate, which is the perfect combination. Accurate and fast. Michael's finished. He's finished. Take about another minute or so. Lexi's finished. Danielle's finished. And Aubrey's finished. And if you two people are not finished, you can pause the video. All right, let's go ahead and take a look at these together. Number 37, straightforward, just add it up, no big deal at all. Aubrey? 8.3 times 10 to the 4th. Number 38, I mean, you have to do some borrowing, but it works out great. No issue here, Michael. 7.8 times 10 to the 8th. And then number 39, 0.1 times 10 to the negative 3rd. No, Evie. 1 times 10 to the negative 4th. Good job dropping the exponent from a negative 3 down to the negative 4. Very good. Number 40, we added up, no good. 12.7 times 10 squared. No, Lexi.
1.27 times 10 cubed.
1.27 times 10 cubed. Number 41, 0.5 times 10 to the 6th. That's no good, Glenn. Ooh. We have 0.5, we're moving the decimal back because the number was too small. So make the exponent smaller. 5 times 10 to the 5th power. Number 42, hey, no issue at all. Danielle?
8.0 times 10 to the negative 7.
Good, 8.0 or just 8 times 10 to the negative 7th. Number 43, 0.2 times 10 cubed. No, Michael.
2 times 10 squared.
2 times 10 squared. Number 44, 13.3 times 10 to the negative 5th. Nope. Aubrey?
1.33 times 10 to the negative 4.
Good. 1.33, and you bump the exponent up from negative 5 up to negative 4. Great job. 1.33 times 10 to the negative 4th. And then number 45 is pretty straightforward, Lexi. We just subtract to get
4.8 times 10 to the 9th.
4.8 times 10 to the 9th. Did anyone go 9 for 9? Wow, several of you. 8 for 9, just missed 1. All right, went the wrong direction on the exponent. I remember that one, Danielle.
5.
You missed 5 of them.
No. I missed like 3 or 4.
Okay, questions on the ones you missed? Do we need to see any of them worked?
Number 44.
Number 44. So obviously the addition here, we've got the matching exponents, right? We've got the times 10 to the negative 5th, which means we're good to add, and of course we're going to get another times 10 to the negative 5th, right? So we're adding the 6.9 and the 6.4, carry, and end up with 13.3. But again, you're not allowed 2 digits. That's too big. So move the decimal over 1, 1.33, and I've got to make the exponent bigger. Well, what's bigger than negative 5? Negative 4. So 10 to the negative forth, and there's our answer. Does that make sense?
Yes, kind of. It's, yeah.
All right. Do we need to see any others worked out, or does that kind of solve it for you?
That's good.
All right, sure. Any other questions, comments on this? All right, your homework for this evening is to do page 90. Page 90, the homework, numbers 1 through 21. Page 90, the homework, 1 through 21. And the exam will be over chapters 1 and 2. That'll be in lesson 40. This is lesson 37 right now as we record. So 38 will be on Monday, 39 to Tuesday, lesson 40 for my YouTube viewers. Plan for that exam in lesson 40. But the homework for tonight, page 90, the homework section 1 through 21. And we will continue reviewing in our next 2 lessons as we look ahead toward your quarter exam. All right, have a wonderful rest of your day. And when the bell rings, you'll be dismissed.